Let's do one last example, and this is an example where we're going to write a rule for g of x again. Our very first thing, we're going to have a g be a translation 2 units up, so that'll be number 1. Then we're followed by a vertical stretch of 2, so that will be number 2. And finally, a reflection over the x-axis, so that is our third and final transformation. And f of x, our original function, is log base third of x. So let's take a look at these in order. Remember that order can be important, so go ahead and make sure you do them in the order that you see them. All right, so number 1, we'll call this h of x, and that's a translation of 2 units up from f of x. So that is vertical and goes on the outside plus 2. So to take our actual function, we'll say log base 1/3 of x and then plus 2. Notice that you cannot put this x plus 2 in parentheses. That would imply a horizontal change and not vertical. All right, it has to be outside the parentheses. All right, number 2, j of x, and we need a vertical stretch by 2. A vertical stretch is going to affect the whole function. So we're going to have 2 times our function h of x. So that's 2 and then parentheses log 1/3 base 1/3 of x plus 2, close your parentheses. So this 2 has to distribute to both terms, right? And that gives us 2 log 1/3 x plus 4. All right, 2 times 2 is 4. Don't forget that that 2 is on the outside. It has to go to the entire function. All right, finally, number 3, and this will be our g of x. This is our final transformation. We need to reflect over the x-axis. So reflections are a negative on the outside. It's going to be negative j of x. So our entire j of x function has to go in parentheses with a negative on the outside. So 2 log base 1/3 of x plus 4, and that would give us a final answer distributing the negative through, just like we did with the 2 above. 2 log base 1/3 of x minus 4. All right. Again, if you didn't quite catch some of this, go ahead and rewind the video and see what you can do with it a second time. If not, you're ready to move on to your assignment.